everyone, welcome back. Today we have another kind of a bonus video because it's a video that I wasn't really planning on recording in this video series because it relates to Sinclair BASIC or Next BASIC, and I'm hopefully planning to do most of my game development using Z80 assembly language and machine code, but BASIC is useful, and today's topic I think is a very powerful and important topic when programming games and programs in general in BASIC. So I'm going to cover it just for any of you who might not already be familiar with it, because it is such an important and powerful tool for us to use in programming games. And today's topic is variable arrays. Now, I'm sure many of you are already familiar with BASIC and variables and variable arrays. So this video is mainly for those of you who are not already familiar with arrays, but they are, like I said, a quite important tool, I think, for programming games. So I'm just going to make this video to cover it so we don't miss anything along our journey for people who are truly beginners and are not familiar with variable arrays. So what is an array? Well, in general, an array I would describe as a collection of similar items that is grouped together in a kind of regular pattern. And I think that description fits well for variable arrays in basic programming as well. Variable arrays are essentially a collection of similar variables that are grouped together in a regular pattern. So it might sound confusing, but it's actually not that confusing, and it's actually very useful. So let's take a look at it right now. Alright, so let's get right into it. As you can see, I've got my ZX Spin emulator open on my computer, and if you want to follow along with me, you can use an emulator such as the ZX Spin emulator, or you can use an actual computer such as a ZX Spectrum computer or the ZX Spectrum Next computer, whatever you like to use. I'm just going to be using BASIC, so anything that you have that can run Sinclair BASIC should work. And here I'm using the ZX Spin emulator. So let's get started. First of all, what is a variable array? Well, there are two kinds of variable arrays, just as there are two kinds of variables in BASIC. There are numeric variables and there are string variables. Alright, so first of all, let's take a look at variables. And for example, if we take a look at numeric variables, because there are two types of variables, numeric variables and string variables. And a numeric variable, as I'm sure you know, is a variable that can hold a numeric value. So if, for example, I could type let a equal 5. And I could say print a now, and the computer returns the value of 5. And there are also string variables, which contain alphanumeric values. And an alphanumeric value for a string variable would be something like an alphanumeric character or a graphics character, or pretty much any printable ASCII character could be assigned to a string variable. And I could assign a string variable by typing, let's say, let a string, and a string variable is indicated by using a $sign. So I'll say let a string equal, and now I just enter whatever the string value that I want this variable to contain. And the value needs to be contained within quotation marks, so I'll put a quote here. And now let's say I give this a string a value of, well, why don't I give it a graphics character? So I'll go into graphics mode here, and then I'll press, let's say, the 3 key, which gives us that line at the top, and I'll exit graphics mode and then type another quote and press enter. So now a string should contain that graphics character, and of course I can check that by just printing a string like this, and it shows us that graphics character I just assigned to a string. So we have numeric variables and we have string variables. And similarly, we have numeric variable arrays and string variable arrays. So let's talk about now what exactly is a variable array. Well, a variable array can be thought of as a multi-dimensional variable. So what's a multi-dimensional variable? Well, if you think of, let's say, a building that has multiple levels or multiple floors, you can also assign multiple levels to a variable, which would make it an array. So these levels are called dimensions. So for example, if I wanted to assign, let's say, 3 dimensions to my a variable, and let me just open a spreadsheet here so I can illustrate that for you more clearly. Alright, so I've got a spreadsheet on the screen now, and I'll just illustrate for you now how variable arrays work. So let's say I have my variable label here, and I'll call my variable a. And so my name of my variable would be a, and I'll just type that here. And let's say the value could be indicated here as, let's say, 10. So a normal basic variable, a numeric variable, would work like this. We give it a name, which is, let's say, a, and we give it a value, which is, let's say, 10. But what if we wanted to use a numeric array now. So the way a numeric array works is we assign multiple levels or multiple dimensions to this variable. And the way we do that is by using brackets and indicating a number to show which dimension or level we're talking about. So for example, instead of just this regular a here, we would change this to a bracket 1. And let's say we want to have 3 levels to our a variable. Then this label here would be a2, and this label would be a3. So each of these levels or dimensions are actually called elements. So a1 now has a value of 10, and now I want to assign values to the other elements. So a2, let's say I give that a value of 20, and a3, let's say I give that a value of 30. Alright, so here we are back in our emulator, and let's create a program now to assign values to a numeric array. So we're going to be using the variable called a, and we'll start by typing line 100 here. And the first thing we need to do before we assign values to these different levels or different dimensions or different elements within this array, we need to actually declare this variable as an array, and we need to tell the computer how many dimensions it's going to have, or how many levels or how many elements it's going to have. So let's say we want our a variable to have 3 elements. So we need to assign a dimension to the a variable, and in this case we want our a variable to have a dimension with 3 elements to it. So to do that, we simply use the dimension keyword, which is shortened as dim, like that, which is on the D key, and we give it the variable name, which is a, and then in brackets we assign how many different elements we want this a variable to have. So let's say we want it to have 3 elements in this case. We just put 3 inside brackets like this, and that will tell the computer to give the a variable, or the a array in this case, 3 different elements. And now we simply assign values to those different elements, and we could do that by typing, let's say, line 200, let a1 equal 10, and then we can bring this down and modify it. So let's say line 210, let a2 equal 20, and then line 220, let a3 equal 30. And if we go back to our spreadsheet and take a look at that, that matches the values that we've outlined in our spreadsheet here. A1 has a value of 10, A2 value of 20, and A3 has a value of 30. So we'll go back to our emulator here, and if we run this program now, those values should be assigned to those different elements of the a numeric array, and we can test that by printing one of them. Let's say we print A2, for example, and this should have a value of 20, which it does. So now we can go back to our program, and we can just enter a little section of code to print these values for us. So I'll just type in line 300 for f equals 1, 2, 3, line 310, print, and then in quotes I'll put a bracket quote semicolon, and then I'll put the number, which is f, and then I'll put another semicolon, then another quote, and then close my bracket, and then another quote, and then a comma to move the print position halfway across the screen, and then I'll put a bracket f. And you can see that we can use variables to refer to the elements within an array. So here, instead of printing a1 or a2 or a3, I'm using the variable f to print that element, so it will cycle through a1, 2, and 3 by going through this for next loop. So I'll enter that, and then line 320 will be next f, just like that. So now this program, when I run it, in line 100 it will assign 3 elements to the a numeric array, and then line 200, 210, and 220 will assign values to each of those elements, and then lines 300 to 320 will print all of those different values for us. So let's run it and see what happens. And there you go, we see we have a numeric array with a label of a, so we have 3 elements, a1, a2, and a3, and each of those has a different value, in this case being 10, 20, and 30. Alright, so let's talk about string variables for a moment again. Now, so if we go back to our emulator here and we assign a value to a string variable, let's say we'll use the variable name n, and I'll say let n string equal the value of hello, just like that. And if I now print n string, it gives me the value of hello. So one thing to be aware of is that string variables automatically have at least one dimension. A dimension is like a measurement, just as you would take dimensions of a house that you're building, or you're measuring something. If you're going to cut a piece of wood, you measure it and you take the dimensions of it so you know where to cut. So in this case, we have a string variable which has automatically one dimension, which is a measurement of its length. So our string variable that we've created here has a length of 5 characters in this case. So just keep in mind that every string variable automatically has at least one dimension, which is its length, which indicates how many characters are contained within its string value. So let's start over again and see how we can use both numeric arrays and string arrays to create a high score table like we might use in a game. So I'm just going to go back to the spreadsheet here, which I've modified a bit by assigning values for a string array, and I've used the label n to represent name, and these are going to be the names of the people who achieve high scores in our high score table. So here we have a string array that has 3 elements to it: n string 1, n string 2, and n string 3, and each of these elements contain a value. N string 1 contains the value of George, n string 2 contains the value of Sue, n string 3 contains the value of Mary. And keep in mind, every element of a string array also has a length associated with it. So although the element in this case is labeled n string 1, which contains the characters that make up the name George, n string 2 has a length which contains the characters that make up the name Sue, and n string 3 has a length which contains the characters that make up the value of Mary. So let's just take a look at that so we really understand what we're talking about here. And if we go back here, and we already have this n string value assigned from our previous experiment, and if I again print n string, it gives us the word hello. But we can also isolate individual characters within this string variable. So for example, if I say print n string and then I put brackets 2 like that, it returns the character e, because e is the second character in our string value of hello. So let's go back to our spreadsheet now, and we'll create a program in our basic emulator to assign these 3 names to these 3 scores in a high score table. So let's go back to our emulator and we'll just clear that out. So the first thing we want to do is dimension these 2 arrays, a numeric array and a string array. So our numeric array is going to contain the scores, and our string array is going to contain the names of the people who achieve those scores. So before we actually assign the variables, let's create some data statements just to hold the data that's going to go into these variables. So I'm going to enter line 9000 here and create a data statement, and now I'm going to enter the values that I'm going to be storing into these numeric and string arrays. And it's up to me how I want to actually assign these values, meaning in which order I want to assign them to which variables, but I already have an idea in mind how I want to assign them. So the way I'm going to store them in these data statements is I'm going to store them with the name of the person followed by the score that they achieve. So let's say in this case I'll start off with my string variable, which is George, and it needs to be enclosed in quotation marks, and then I'll follow that with a comma, and he got a score of what? A score of 10. So George gets a score of 10, Sue gets 20, Mary gets 30. So back to my emulator, George gets 10, comma, and then I'll enter Sue, comma, 20, comma, quotes, Mary, quote, comma, 30. So now we have a data statement that contains all the data we need to store into our both numeric and string array variables. So now let's create our program starting at line 100, and we need to declare these variables by assigning them dimensions. So we'll use the dim statement, which is short for dimension, and let's start with the numeric variable, which is going to have 3 elements. So it's going to have a name of, let's say we'll give it a name of S to represent score. So we'll say dim S, bracket, 3, close bracket, enter. So now I have a numeric variable array which has 3 elements. Since this is a numeric variable, we don't need to assign it a length. And now let's enter line 200, and we'll assign a dimension to our string variable, and let's call that one n to represent name. So I'll assign the n string array by typing dim n string and then open bracket, and then I'm going to give it a number of elements, which is how many names are going to be on our high score table. So in this case we have 3 names, so I'll just put the number 3. But now remember how we just explored the fact that string variables already have one default dimension to them, which is their length. Well, we need to actually assign that length when we're creating a string array. So in this case we have to choose how many characters are going to make up each name in our high score table. So let's say we want to allow names that have up to 8 characters in them. So here I'll just put the number 8, and that means we're going to be assigning a variable string array called n, which has 3 elements or 3 names, and each name or element can have 8 characters. And I'll close that with a bracket and press enter, and that's done. Now one thing we have to keep in mind is that when we assign a string array like this and we tell the computer how many characters each element will contain, in this case 8, even if we assign a name that has fewer than 8 characters, that particular element is still going to contain 8 characters, and the computer will just pad out the unused characters with spaces. So in this case each name will actually contain 8 characters, even if those characters are not all letters. Any unused letters will be assigned spaces. So let's go ahead now and assign the values to these 2 variable arrays using a loop. So I'm going to create a for next loop, add, let's say, line 300 for f equals 1 to, and now the number of elements that each array contains is 3, so I'll put 3 here. And then at line 400 I'll actually assign the values to each of these arrays. So now if you take a look at the way I've created my data statement, you'll see the name comes first. So although we dimensioned the arrays starting with the numeric array and then followed by the string array, since my data in the data statement starts with the string value, I need to actually assign these values in that order. So I'm going to start off by assigning the string values. So I'll do that using a read statement. So first I'll assign the string value by typing read n string and then open bracket, and I'll use the loop variable of f to indicate which element in this string array we're interested in assigning. So I'll put f here, and then I'll close my bracket and press enter. And then in line 500 I'll assign a value to the numeric array. Since each name in my data statement is followed by the numeric value of their score, I'll say read s open bracket f and close bracket and press enter. So that will assign the numeric value to our numeric array of s. And then finally line 600 I'll say next f. So line 100 declares my numeric array, line 200 declares my string array of having 3 elements, each of which being 8 characters long, and then lines 300 through 600 read the data from our data statement and assign those values into both of these variable arrays. So now we need some code that will actually print these values for us, or we're going to print our high score, and let's do it properly this time by entering line 1000 rem print high scores, just like that, and then line 1100 print high score table, and I'll set up another for next loop 1200 for f equals 1 2 3 line 1300, and now I want to print both the names and their scores. So their name is held in the n string variable array, so I'll say 1300 print n string and then open bracket f close bracket comma, which moves the print position halfway across the screen, and now I want to print their score, which is held in the s variable array. So I'll put s open bracket f, which is our variable used in our for next loop, close bracket, enter, and then finally line 1400 next f. So hopefully this all makes sense. What it's going to do is assign all these values to these arrays and then print all the array contents, which are the values of both the string array containing the names of our high score people and the values of their scores, which are contained in the numeric array labeled s. And I'll just enter one more line here at line 1150 to print a blank line to separate the title from the contents of our high score table. And now let's go ahead and run the program and see how it looks. And there we go, we have our simple high score table that is made up using arrays, a string array to hold the names, and a numeric array to hold their scores. Now the next thing we need to cover is an even more powerful aspect of arrays, which is their ability to be multi-dimensional. And now what do I mean by multi-dimensional? Take a look at this numeric variable a again, and I'll just zoom it in a bit more. So now, an interesting and powerful thing about variable arrays is that they can contain multiple elements. They don't just have to contain one row of elements like this one does. So for example, let me just erase these two cells here, and I'll erase these values as well. And I'll just outline exactly what I mean. So if you imagine this A array right now, it has 3 elements, and you can see they're all on the same row. But what if we added a second row to this A array? Let's say we copied this, and we moved it down here. So now row 2 also contains 3 elements. But we need to tell the computer about this second row of elements, right? So since we now have an array that contains 2 rows of elements, we need 2 different values inside these brackets here. So now the first number within the bracket will represent the row, and if I put a comma here and I put another number, that will represent the column. And so here you can see this cell that I have highlighted represents row 1, column 1. And then I could do the same for this value here. I could put another number before this 2 to indicate the row. So row 1, column 2. And the same for this one would be row 1, column 3. And I'll do the same for this one. And this would be row 2, column 1. And this would be row 2, column 2. And this would be row 2, column 3. Just like that. And each of these elements obviously can contain their own value as well. So now that we can see how this is pictured in a grid like this with the rows and columns indicated within these brackets, let's just move these row and column values outside of the cells so we can assign values to this variable. So up here I'm going to put the name of the variable, which in this case is A, and this will be my row numbers here. So I'll put row 1, row 2, just like that, and these will be my column numbers, column 1, column 2, column 3, just like that. And now if I erase these values, I can enter the actual numeric values that I want these individual elements to contain. So let's say I want this element to contain the value of 10, and this one will be 20, and this one will be 30, and then this one will be 100, and then 200, and then 300. And of course you can pick whatever values you like. These don't have to be following this particular pattern that I've set up here. You can put whatever values you like. You could put a value of 3 here, or you could put a value of 7 up here, whatever you like, right? I'm just using these even numbers so that it's easy to remember when we do our demonstrations. So let me just change these back so they're easier to remember. I'll put this back to 30 and this back to 200. And how would we assign this in our program? Well, if we go back to our emulator here, let's start fresh now so we're not confused, and I'll just enter new here to start fresh. And this is what we want to end up with. So here we want to end up with the numeric array, which has 2 rows by 3 columns. So let's go declare that in our emulator. So let's enter line 100 here, dim A, open bracket, and then we put the number of rows if you want to think of them as rows. So let's say in this case we have 2 rows, so we would say 2, comma, and then the number of columns, which is 3 in this case. Just like that. And now in this case, since we have 2 elements we need to worry about, we need to assign these values using a nested for nest loop, which has 2 levels, which is not that complicated. All we have to do is, let's say, enter line 1000. Why don't I use the letter C for column and R for row? So we want to do the rows first. For R equals 1 to 2, since there are 2 rows, and then line 1100. I need another for next loop now for the columns. I'll say for C to represent column equals 1, 2, and we have 3 columns now, so I'll put the number 3. So now we have a for next loop to assign a row value and a for next loop to assign a column value. And at line 1200, I'll just put a read statement to actually assign those values, which we'll put in a data statement later. So we'll say read, and then our variable array name, which is A, and our open bracket. And then now we simply can use these variables for the row and column. So I'll put R, comma, C. Simple as that. Enter, and then 1300. Next, C to close off our column for next loop, and then 1400. Next, R to close off our row for next loop. And now of course we need a data statement containing the values we want to assign. So I'll put line 9000, data, And now what data values do we want? So remember, our inner loop is the C, or the column values. So our row will start at 1, counting from columns 1 to 3. So if we look at our spreadsheet, our row will start at 1, counting from columns 1 to 3. So the column 1 to 3 values are 10, 20, and 30. So I'll just go back and enter those values into our data statement. 10, 20, 30. And if we want, we can just enter this data statement by itself to give us a visual representation similar to our spreadsheet. So this could be the top row, for example. And then we could enter line 9100, another data statement. And now we can enter our second row of values, which is 100, 200, 300. So 100, 200, 300, just like that. And now this program should automatically read and assign values into all of these different elements of our A array. So let's run it and give it a try. And let's just do a quick test to see if it worked. So let's choose a value we want to inspect. Let's say row 2, column 3, which would be a value of 300. So let's go back and print that manually by saying print, and then our variable name, which is A, and then open bracket, and then it's row 2, column 3, so we'll put 2, comma 3. Very simple, and we press enter, and we get a value of 300, which corresponds perfectly to our row 2, column 3 value right here of 300. So it's fairly simple to assign values to a two-dimensional numeric array. So now you might be wondering, can we add even more dimensions to an array? More than 2. So in this case we have a numeric variable array which has 2 dimensions to it, meaning it has rows and columns. But what if we wanted to assign a third dimension to it? Is that possible? Well, yes, it is. So if you imagine, let's say, a Rubik's Cube, that would have 3 layers of 3 rows by 3 columns. And we can do the exact same thing here with our numeric array. And I'm going to just move this down to here so we can see it. And let's move our A label out of this layer here and just move it up there. So now we have a single layer with 2 rows and 3 columns. And let's erase the values within these cells for now. So now we have 1 layer, and I'll just put a border around that so we can see it. Just like that. And I'll call this one layer 1. And now we need 2 more layers to make up our Rubik's Cube. So I'll just copy this grid here, down here, and I'll call this layer 2. And I'll copy this again down here, and we'll call this layer 3. So now you can see our A numeric array will have 3 layers to it, each layer having 3 rows and 3 columns. And this might seem kind of complicated and confusing, but it's really not. All we have to do is add another dimension to our variable in our basic program. So if we go back to our basic program here, and we see how can we modify this now to add all these new elements. Well, let's go up to our dim statement here, and we'll bring it down. And right now we just have a single dimension statement that has 2 rows by 3 columns. Well, we already know we added another row, so we need to change this 2 to a 3, and that will give us 3 rows by 3 columns. But now remember, since we have a Rubik's Cube style of A array, we need to add 2 more layers. So we're going to have an array that has 3 layers by 3 rows by 3 columns. And we'll press enter. And that means, of course, we're going to need a third for next loop to assign values to each layer. So let's use a new variable called L for layer. And that needs to be outside of these 2 loops because each layer contains both rows and columns. So let's start this at line 900. And this will be for L for layer equals, and we have 3 layers, so this will be 1, 2, 3. And now we just need to close off this loop here, and we do that last. And so let's put that one at line 1500. So 1500, next L for layer. And now we need to modify our read statement, of course, to give it a third element also. And so we already have our row and column elements. Now we just need to add our layer element. So we'll put L here for layer, comma, and then enter. And now we're going to need more data. So in this case, let's modify the data so it's very obvious which data goes in which cell. And the way I'm going to do that is just by using the layer, row, and column values to make up a number. So for this cell it would be layer 1, row 1, column 1, and then layer 1, row 1, column 2, then layer 1, row 1, column 3, and then down here would be layer 1, row 2, column 1, and so on and so forth. So I'll just go ahead and fill in these values now. Okay, so there we have our completed table of values for this three-dimensional numeric array labeled A. And now I need to copy these values into the data statement of our program, which I'll do now. And there we go, all our data statements are entered now. And one more thing I just noticed we need to do here is change line 1000 to make our row loop count to 3 as well, because we used to have 2 rows and now we have 3. So there we go, we have 3 loops representing the layer, the row, and the column, counting from 1 to 3 and assigning all these values in our data statements, which should match these values that we have in our spreadsheet. So let's go ahead and run that program and see what happens. So now all the values should be assigned to our A numeric array, and if we test that by typing print A, and then we'll just enter 3 random elements. Let's say we want to see the value of layer 3, row 3, column 3. We can just enter 3, 3, 3, and then close bracket, and this should give us a value of 333, right? Because if we look at our spreadsheet, we have layer 3 here, row 3, column 3 should equal 333. So let's go back to our emulator and hopefully we'll get a value of 333, which we do. So now you can see how easy it is to create a multi-dimensional numeric array just like we've done here. There are plenty of other uses for a multi-dimensional array, and we can even add more dimensions than this. So what could we use a multi-dimensional array for? Well, for example, let's say we create a multi-dimensional adventure map. So each value in these cells could represent how many monsters are in that particular room for that particular layer. Now what if we wanted to do the same trick using a string array? What kind of interesting things could we do there? Well, that gets even more fun, because let's say we modify the data in our string array to again represent a dungeon or a map, and that contains different objects or different room names. I'm just going to modify the basic program now and see if we can have a little fun with that and see what I can come up with. So just give me a minute here and I'll come back and I'll show you what I've done. Alright, so I'm back and I've finished modifying our program to make use of a string array this time. And let's take a look at the screen and see what I've done. So first I'm just going to go down to the very bottom of my program here. So here you can see, starting at line 9005, I have a whole bunch of data statements which contain both graphics and alphanumeric characters with these letters here. And these graphics and letters are going to be stored into our string array. So let's go back to the top of the program now and take a look. So if you look at line number 10 here, I have 3 variables. I have a numeric variable called level, which I've assigned 1. I have another numeric variable called y, which I've assigned a value of 9. And I have a third numeric variable called x, which I've assigned a value of 5. So level represents the level of our maze, since I have 2 levels in my maze, and the y and the x values represent the y and the x coordinates of my character that's going to be going through the maze. And now let's see how these graphics elements get assigned into our string array. And that happens right here. First of all, at line 100 here, you'll see we're using the dim keyword to dimension our string array. And our string array has a name of A string right here, and it has 3 elements, 2, 10, and 10. So our string array has 2 levels, and each level has 10 rows, and each row contains 10 characters, and those 10 characters are the characters we just looked at in our data statements. And now in order to assign all those graphics characters into our string array, that gets done right here with these 2 for next loops at line 900 and line 1000 here. We have a for next loop that has an L counter and a for next loop that has an R counter, and the L counter counts from 1 to 2, that represents the levels of our maze, and the R counter counts from 1 to 10, which represents the number of rows in our maze. Now we don't need a third for next loop to assign the individual characters to each element in our string array, because if you take a look at our read statement right here, it reads A string, L, and R. So when it reads A string, L, and R, it reads that entire line of characters into that element. So L and R represent the level and the row, but we don't need to define the individual characters to be brought into that array, because it brings that entire line. Just as if we were assigning a single value to a string array, For example, we could say let a string equal hello. Hello obviously contains more than one character, so we assign all the characters at once, and we're doing the exact same thing here. When we read a string LR, an entire line of characters will be assigned into that a string element. So this is just kind of a fun example of what we can do with a string array, and let's go ahead and run the program now and see how it works. So I'll type run here, and there we have a bit of text at the top that just has a label showing the name of our game, which is called Treasure Hunter. And then here we have some letters that represent the different elements that can be found in our maze. You see we have a T that represents treasure, P that represents potion, M that represents a monster, E that represents the exit, and also there's a secret element here, which is the S character down here, which we will save that as a surprise for a bit later. And now if you take a look at the bottom, you see there's an input prompt here that says which direction, north, south, east, or west. So now we simply enter one of those characters. Let's say I enter north, and we're starting off, as you can probably guess, right here with our little flashing asterisk here that's flashing red and blue. That's our adventurer in our maze. So right now he's at the bottom of the maze on level 1. So I'm going to just enter the character N so he can go north. And then you see he moves up one space. And let's see what happens if we try to move him north again. So now when we try to move him north again, the program automatically detects that there's a wall in front of him. And the way it does that is by detecting what character is in this string array. So the program checks to see which graphics symbol is in the position of this string array that our character is trying to move to. And if it detects a block, then it knows that's a wall. So let's try to move in a different direction. Let's say we'll go west here and move him over to this E letter. And when he's over the E letter, we get a message that prints you found the exit. So E represents exit, and the program can detect all these different elements in the maze. So you can see how kind of fun and interesting and useful it is to use arrays, both string arrays and numeric arrays, in particularly making a game or any type of program for that matter. So I can just move this character around now, and we can adventure on and explore all these other different things that are in the maze here. And if I go up here to this M, we'll see what that does. Monster attack. So M stands for monster, and we have a monster attack, which is no good, so we better get away from him. And now what if we go over to this T right here? Ah, we found the treasure. So you can see how interesting it is to use arrays in a game, and it's quite an easy thing, but a very powerful thing to use when making a game in BASIC. And now let's go and check out our surprise, which is down here in the bottom right corner. So I'll go all the way down here, and when I move our character over the letter S, it displays a message saying that we've entered a stairwell. So obviously that stairwell could bring us down to level 2, and then we could keep on adventuring and find all kinds of new and fun stuff in level 2 of our maze. So that's pretty cool. So there's just a kind of a fun example of how useful and powerful it is to use arrays in our programming journey, and we can use them to keep track of numeric values or graphics values, such as in this case we created an entire maze using some simple graphics characters. But obviously you could use arrays in a much more complex way than I've done here. You could use them to keep track of all sorts of different values in your game, and you can make them as simple or as complex as you like. Now the one thing to keep in mind with arrays, however, is that as soon as you assign these arrays, they immediately take up space in memory. So just because you haven't assigned any values into an array doesn't mean that they're not taking up space in memory. So if you have a very large array, let's say a multi-dimensional array, then that will take up space in memory the moment that it gets defined in your BASIC program. So we need to just be careful to make our arrays no larger than we need to, so that we make sure we have enough space to hold all the data that we plan to store in our arrays. And the different arrays obviously take up different amounts of memory depending what type of data we're storing in them. So for example, a numeric value would take up more space than a character value. So there we go, there's one more tool in our game development toolbox that we can use next time we're programming a game in BASIC, and feel free to go ahead and give it a try and see how you can use arrays in your game. Thanks for watching, and we'll see you next time.